Assalamualaikum and greeting everyone. My name is Muhamad Syariz Syazwan bin Amran from Bmmm student and this is my slide presentation. The title of my PSM is Effect of B20 and B30 pump oil biodiesel on performance and exhaust emission of a diesel engine. I'm supervised by my supervisor, Dr. Muhammad Taufik bin Taib. First, let's begin with presentation outline. Firstly, introduction, which consists of background of study, problem statement, objective, and scope of research. Next, literature review, which consists of feedstock for biodiesel production, transesterification process, engine performance, and exhaust emission. Finally, methodology, which consists of type of feedstock, type of machine, biodiesel production, blending process, identification of engine parameter, and preliminary finding. At this session, I will explain all content that consists in introduction. Due to the expensive cost of raw vegetable oil, biodiesel was created quickly and becoming an environmentally benign alternative to diesel. The research goal was to identify suitable alternatives to petroleum oil, and biodiesel is today one of the finest options. Palm oil as a main raw material is economically viable. Malaysian palm oil can compete with the price of Middle Eastern oil crops cultivated domestically in the EU. For example, Malaysian palm oil biodiesel is still quite inexpensive. Biodiesel has been cultivated during the late 20th countries in Southeast Asia. Palm oil was in massive demand for candle making and machine lubrication during the 18th country's British Industrial Revolution. Indonesia and Malaysia can contribute 80 to 85% of global capacity, invested in developing multiple techniques to convert palm oil into biodiesel. Since the 1980s, Malaysian Palm Oil Board (MPOB) has been at the forefront for palm biodiesel research and development. The MPOB has accomplished its goal. Next, let's move to problem statement. As the price of oil grows day by day, more people are converting to biodiesel to save money and lessen their dependence on fossil fuel. The combustion process happens in the chamber for biodiesel. Diesel blend has produced torque to the engine and smoke through the exhaust system. The combustion process causes a number of issues. First, difference of various biodiesel feedstock used affect the characterization of biodiesel. Second, palm oil as biodiesel feedstock will generate difference in engine performance. And the last one, palm oil as a biodiesel feedstock will generate different exhaust emission by the gas analyzer. As a conclusion, biodiesel is a compatible alternative of diesel derived from fossil fuel. Objective for this project is: first, produce biodiesel using the transesterification process. Second, analyze the diesel engine performance of B20 and B30 biodiesels. And the last one, to investigate the exhaust emission of B20 and B30 biodiesels. Scope of research for this project: first, biodiesel manufacturing using palm oil as a feedstock. Second, engine performance tests, brake power, specific fuel consumption, and torque. And third, exhaust emission CO2, CO, HC, and NOx by gas analyzer. Now, we move to the literature review. There are some literature reviews that have used: first, feedstock for biodiesel production. We have used biodiesel production from palm oil, its byproduct and mill effluent, a review by Zahran and Kano, 2018. This article says biodiesel can be produced most efficient from palm oil because of its high concentration of palmitic and oleic acid. Next, transesterification process. The article that used the effect of reaction time and temperature on the synthesis of methyl ester sulfonate surfactant from palm oil as a feedstock using microwave-assisted heating by Kadaria 2021. The article says palm oil transesterification yield up to 98% methyl ester with having a kinematic viscosity of 3.149 cst and a density of 0.8585 gr per ml. It has been proven to be in compliance with the SNI 7182-2015 biodiesel standards, having a kinematic viscosity of 2.3 to 6 cst and a density of 0.85 to 0.89 gr per ml. Because the glycerol chain is disrupted in the intermolecular interaction in oil, palm oil and methyl ester have different density and viscosity. Next, engine performance articles that have used are potential of waste cooking oil biodiesel as renewable fuel in combustion engine, a review by Jacob 2021, and performance and emission characteristics of CI engine fuel with palm oil methyl ester blend with diesel fuel by Guide 2018, and finally, exhaust gas emission characteristic articles that have used are potential of waste cooking oil biodiesel as renewable fuel in combustion engine, a review by Jacob 2021, and the effect of biodiesel fuel on diesel engine emission by Abbott 2019. In the article, engine performance say about brake power, the amount of power generated at the output shaft by the engine is referred to as brake power. Biodiesel and its mix have a lower heating value than diesel. This is resulting in a reduction in power. This is due to PO biodiesel low heating value. For torque, biodiesel fuel has a higher viscosity than diesel but a lower calorific. Higher amount of biodiesel fuel in this blend reduce engine torque. Fuel spray characteristic may be improved by raising torque, which raise the fuel injection pressure and improve flow. Next is brake thermal efficiency. The ratio of the injected fuel's power output to its energy output is referred to as thermal efficiency. Blend of biodiesel have a little lower thermal efficiency than diesel fuel when the engine is running at full power. Palm oil biodiesel has poor combustion properties and instability. Next, the last part for the engine performance is brake specific fuel consumption. The quantity of fuel spent per unit of energy at the output shaft is known as specific fuel consumption. From this graph, we know as palm oil-based biodiesel blend have a higher specific fuel consumption rate. For all blend and diesel study, SFC decline as brake power increase. Now, we move to exhaust gas emission. Exhaust gas temperature. For all fuel, the temperature of the exhaust gas increases as the engine load increases. From this graph, for the fuel engine load, biodiesel blends provide higher exhaust gas temperature than fossil diesel. Higher oxygen percentage help the combustion process. Exhaust gas temperature for diesel fuel has increased. For smoke opacity, smoke in exhaust emission is created by incomplete fuel combustion. An engine with fewer smoke emissions are a sign of better fuel combustion. From this graph, smoke emissions of biodiesel blend were lower than diesel fuel due to the oxygen in the molecular structure, resulting in improved combustion and lower smoke emission. For CO2, exhaust gas temperature and compression ratio are two important elements that determine CO2 emissions. From this graph, CO2 emissions for biodiesel blend were lower than diesel oil, and it is increased with the increase in blend proportion. Biodiesel burns more gasoline at higher load and has more oxygen available in its molecule. For CO, due to reduced automation, the higher viscosity of the palm oil mix typically increase CO emission in unmodified engines. From this graph, CO emission drop with increasing engine load at part load, then increase at full load or all test fuels, because biodiesel blends had more oxygen molecules and had a lower carbon content than diesel fuel. Next, for HC, increased HC emission may be a consequence of prolonged ignition delays when fuel builds in the combustion chamber. From this graph, all test fuel had lower HC emission at half engine load but higher emission at full engine load. Biodiesel blend with diesel fuel produce lower HC emission at all engine load compared to diesel fuel. The last one for gas emission is NOx, known as nitrogen oxide. NOx was produced in the exhaust of CI engines due to the thermal NOx procedure. From this graph, all biodiesel mix had higher NOx emission than diesel oil. This is because more fuel is burned. So now, methodology. Problem statement. Second, literature review. Third, biodiesel production. Fourth, engine preparation. Fifth, biodiesel testing in engine. And the last one, data collection. Palm oil was chosen as the feedstock for making biodiesel in order to study the performance and emission of a diesel engine. The percentage of palm oil biodiesel blend used is between 20% and 30%. This project used a 125 HP blower cooled AC engine dynamometer to assess the engine output, braking power. The machine provides an AC generator with a maximum electric power output of 10.5 kW, a load controller and other auxiliary items that were directly attached to the test engine. Various exhaust gas emissions such as CO, HC, and NOx were measured during a MRU data 1600/V gas analyzer. For this project, we do not do transesterification process, but we just do blending process. It takes about 30 minutes or stir to attain equilibrium of the mixture biodiesel and diesel. To see how the blending process takes place on the next slide. This is the specification of the engine. We use engine model 170FA, that one-cylinder 4-stroke engine. To see how biodiesel will test in this engine, take place on the next slide. So this is the current result for the previous test. We use biodiesel as a preliminary finding first before we use for the biodiesel for PSM2. As a conclusion, all the results stated in the theory are proof for this biodiesel. So that's all for my PSM presentation. Thank you.